Okay, what time does the music trip leave in the morning?
Morning 6. I think.
Lucky man. Nope, he can come in before school starts.
Okay, so,
If I played you the course, you would get it away.
okay, you have a quiz on vectors tomorrow. You should have picked the packet up on the way in. Did you, yes or no? Peter, get off the phone. I should go back and watch the videos of how many times do I say that. Alright, so, all things vectors. I don't care so much that you guys have these definitions, but I'd like to know, do you at least have an idea of what they are? Try writing something down. What do you think?
I think.
Just write down. Write words down.
So it's okay if I get it wrong.
I'd like you to have an idea. I'd like the idea to be right. Exact words, not so much. I don't think I'm. Yeah.
That's kind of ironic that I was Wow, you're trying. One shepherd. I got my sweatshirt bag up.
Nick, what's going on in this class tomorrow?
We have a test. Or a little test. Quiz.
Real quiz.
A test, a little test, a quiz, an exit card, or a homework check. Which one? Quiz.
That's us. A little test quiz.
Okay.
I said a little test quiz.
Yeah. All right. So it's a quiz. Today is a review for it. There is a progress check that is required by the county that is on Friday. A piece of that will be on, go into gradebook also. This here. Okay. So, Nick, how would you describe or explain what a vector is?
I'd say it's like it's something with direction and magnitude. I didn't really get much further than that, but
You're late so much that you have missed weeks of time. You're asked coming in at lunch. Okay, so it's something that has direction and magnitude. Peter, how do we physically represent, like draw what a vector is? Something that starts the origin of the graph?
Yeah, you draw it out. Whichever direction.
It's missing something.
Oh, we're trying.
An arrow. I'm missing an arrow because it didn't tell you the direction until I put the arrow on it. Because what if the arrow was at the other end?
Because then it would have been going that way.
Then it would have been going the other exact opposite direction. I'm like,
Quadrant 2
hey,
instead of quadrant.
go to Canada by way of Mexico. You will get there eventually, but you got to go a long way around.
Yeah, I was like traveling.
Okay, what does magnitude mean, Alan?
I said like the way like the line is traveling, or the distance the line is.
Okay, the way the line is traveling sounds different. The length, what would you
The
say?
angle.
What?
The angle.
Okay, is angle magnitude?
No.
Angle. Okay. Magnitude
I think it's how long the line.
is the length of the vector,
Oh, what?
strength of the force. It's the speed. It depends on what the vector means. Like, if I pull the desk, there is that much force pulling this way. So the magnitude of the vector, I was pulling whatever amount of weight Tycho is, and the direction was this way. No. So the direction, you have us running 5 miles an hour north. the wind was blowing 750 miles an hour southwest. The direction was north, was southwest, 45 degrees west of south. It's the angle that the vector is going. Component form of the vector, Fernando, give me an example.
Like numbers in here? 6 and 9.
And then, as Peter said, what that would graph like is if you started at the origin and plotted the coordinates 6, 9, and then drew from the origin to that with an arrow. So that's component form.
Oh, I just did this x comma y.
Yeah, so the general is x comma y. And what that means is go x amount right or left, go y amount up or down, plot that dot, and draw the arrow from the origin to that spot. Cool? So Monica, we go with, remember just basics of what vectors are. Yesterday's homework. First of all, did you guys do it?
Yeah. Do you want to see it?
Sure.
Okay.
Preguntas?
Yes. Give me a second.
Did you pull it out?
Yeah.
I got like 2 that were
Do you have the homework or not?
So
No?
Yeah.
so
I got 2 that were
Question-
perpendicular.
question 5 and 33.
Oh, no, I tried.
Do you have them or no? Okay, what was your question?
I just didn't really. I mean, I did 5 and 33, but I kind of wanted you to like go over them.
5 and 3,
33.
30.
5 of which one?
5 of the second section.
There's 3 on the other page.
I did.
Yeah, I didn't do the rest.
I mean, it's more.
What? Yeah, I did more than that.
Okay, so number 5, question on that one? No, I'm sorry. What was
Yeah.
in the second section? Okay, well, first of all of these, the answers are of the form whatever the magnitude is times cosine of the angle, comma, magnitude times sine of the angle. So if we don't specify, choose how to round, choose something reasonable. And 3 decimals is what AP Calculus wants, so we often in pre-cal try to get you trained for that 3 decimals, 3 decimals, 3 decimals. But it's a lot, and you guys are like, okay. If it doesn't specify, choose something reasonable, and for calculus, 3 decimals is what they always ask for. So, no issues with the first 4? Yeah.
Because I'm not asking you for the magnitude, because it has like the in the.
This thing, that symbol, the
Yeah.
vector in that is the magnitude. So this is saying magnitude of A equals 11. It's 11 miles an hour. It's 11 pounds. It's 11 whatever that force is. So that little bars means the magnitude already. Mara?
What like setting should my calculator be in? Because I do that for the other I used to.
You need to be in degrees when we give you degrees, so my guess is you're in radians. Any other technical issues with those first four? Dot product, it's not multiplying really. You're gonna end up with a single number, you don't get vectors out of it. But you do the x times the x and the y times the y, and you add them together. If it's a positive dot product, that means the two vectors are kind of going in the same direction. They might be going exactly the same direction, we need to check some things. I then will,
In number 5, I don't know where is the I and J you go.
the I and the J.
That's what I'm saying.
So in the, when you do things with vectors and get into more complicated things with physics and physical motion, they will use this I, J, and K. K being up. But just needed you to see the notation that they might use. Some IB people might be using the I, J, and K. If you go into physics, you're gonna get I, J, and K. But writing it in what you expect. There was no J stuff, so that one's just a 7 and a 0. Sarah, question?
Wait, were we supposed to only do the one circle?
Yes.
Oh. So I'll be doing too much homework.
Okay. Following the directions that say circle problems.
What's good practice?
Okay, are these guys perpendicular? No, because
It's not 0.
the dot product is not 0. Are they parallel? Maybe, maybe not, we need to check. So this one, the slope of u is 3/5. The slope of v is 4/12, which is 1/3. Are those slopes the same? So are they parallel?
That's her.
So what would we say these two vectors are doing?
They're going to the same place, but.
They're not perpendicular, they're not parallel, we would call them, they just, wind is blowing that way, your wind is blowing that way, you're both going kind of the same direction, but not exactly.
With dot.
Yeah.
With dot product, like, obviously, I feel like the 72 shows a stronger correlation that it's going in a similar direction versus the 30, the
Yes.
0. Is there a limit? Is it like a decimal place where it's like you get to 100 and showing a perfect correlation? Or can it go
no.
like to 1,000?
It could be any huge number, any number at all, because it maybe the earthquake was, whatever, maybe the wind was super, super strong, and you were running super, super fast, or flying like Superman, I don't know. So the dot product could be thousands. It just means, how, you're right that they're helping each other more in some way than this one, but they're both. Graph the middle show. Yeah.
Are parallel or orthogonal?
Orthogonal, what does orthogonal mean? Does it mean parallel?
Perpendicular.
It means perpendicular. Sorry that they use more than one word for that. And when you get in physics people, you're in physics, right? No? What's the normal force?
Normal force is the force that when some object is having some surface and the normal force acting perpendicular toward the surface.
Okay, normal force is perpendicular. So if you are on the roller coaster and you're whipping around on the tracks and you don't actually get pulled off the tracks and thrown off into oblivion, because we love you, we want you to live. But we want you to have the thrill of like, woohoo, scary, almost being thrown off the tracks. The normal force perpendicular is what keeps you on the track. Sorry.
What's the centrifugal force for one that would throw you off the track, right?
I don't know centrifugal versus centripetal. One of them, centripetal force, I believe, is like an imaginary force.
Yeah, I don't think centrifugal. I remember it was doing centrifugal and you had a pendulum you could swing it around, like see how hard it would land out.
Yeah, my physics is now really old, like it's from the 90s. So, but I know this one. Okay. Questions on these guys? There were only a couple. 4. Determining if it's perpendicular or not, parallel, perpendicular, or neither. If dot product is 0, they're perpendicular, also known as orthogonal. Again, dot product was 0, so they're orthogonal. Here, dot product was not 0, so they're not perpendicular. However, when I did the y over the x, the slopes came out the same, so they're parallel. And this dot product's not 0, so it's not perpendicular, and the slopes weren't the same, so they just cross neither of those. They're just being vectors. Cool? Okay. Okay, can you guys do these two? Check with your partner.
This way.
Ask your partner.
Yeah.
Serene, do you have a packet? Serene, did you pick up a packet on the way in when you came in late? Okay.
These are all mean.
The direction.
You
You write it like this.
Direction, I want an angle, an exact, precise, calculated angle. So what you have there is not correct.
How do you get that?
I don't know.
I'm like
William, think back to when we did trig. How do you do it? No. Just trig. Just trig.
Oh, yeah.
like the one we made yesterday.
Work up to get the
I can do the fraction of the vector.
Oh yeah, it's easy.
We're gonna find the vector first, because I gave you coordinates. I didn't give you
Yeah, so I'll find the vector equal to
Sine
whatever vector is squared.
the x
opposite over.
For the direction is it A minus B or B minus A?
No.
It's internal minus initial.
All right. Good questions.
Let me do it now. I'm ready, girl.
Alvin, did I give you a vector, or do you have to find the vector first? Crap, how did we find the vector? How do I find vector AB?
I remember.
Well, Alvin, how do I do it? So that they asked for vector AB, that's a very different thing than BA. Are you going from Canada to Mexico or Mexico to Canada? There's a difference. So Roscoe, how do I find actual vector AB? Alvin said subtract A from B.
The end is B, and it starts at
So
-2 minus 2, and then 6 minus 1, which is the same as 6 plus 1.
okay, so did you guys hear him? He said the ending x value, so B, -2 minus the beginning x value, 4 or 2. -2 minus 2 is -4. Then he said the ending y value for B, 6 minus the -1 is the same as adding, so he said 6 plus 1 is 7. Okay, and Tay, then you said, how did we do the magnitude?
Like,
The square root and
Okay,
rooted.
rooted. Rooted. What am I rooting?
-4 squared plus 7 squared.
So,
root 65.
and personally, I don't like rounded things. Square root of 65 looks fine to me. But if it said, give me some decimals, I do that. Peter, how do I find the direction?
Sine -1, 7 over root 65. I got 60.358.
Okay, and that would be incorrect, and it's not really the way we want you to do that. I mean, okay, so we do have the 3 sides of the triangle, but I'd like you to use the ones that we have.
Wouldn't it be y over x, tan inverse of y over x?
Yep. And inverse of the y over the x. And Peter, you were close. And we're gonna get a problem with this one too,
You not
so,
do signs?
okay. You can do sign and don't. It means that you don't understand what's going on. Like, if I don't ask you for the magnitude, but I just give you this vector and say, find the direction, you'd be doing a calculation you didn't need to do. Like, can we find this with this x value and this y value? Yes, we're gonna use can. Nick, what do you get?
That's grab that.
There's some in the back. It's negative 60. Okay, so Gianna got negative 60.3, 63 or 60. Okay, so negative 60 degrees, rounded. Is that the answer that I want? No, I want the answer that's over here. What do I need?
300. 180 minus 300.
Just add the 180. So the direction, the real angle is 120. So Peter, I think you got 60 degrees. You flipped it around and put it in the first quadrant. If you know what you're doing, I mean, you can do it that way, but you gotta make sure you get the angle, whichever angle it ends up being, in the right quadrant. Okay? All right, you guys do the next one. Number 2.
I thought, can you do this? Do minus, isn't it initial
Right, that's the
minus 6, minus 3, and minus 8?
Do the next one.
No, but I need to go to the bathroom bad.
Got a shortcut. Minus 6, minus 3, then minus 8.
Zero minus.
I don't remember. It's supposed to be fixed. Minus 6, the first minus 5, the second.
End minus start. Which coordinate are we ending with? And you gotta
Oh,
read,
it's end minus start. That's
Yep.
so it's 3 minus 6. Okay, cool.
but you gotta be careful because sometimes they'll be like, here's these coordinates, A, B, C, D, E, F, G, and they'll be like, what's the coordinate G, A? So make sure you know which way it's going.
Minus 3, minus.
You don't know who was late. Do you remember the usual substitutes?
So you do tangent again. Like this. Tangent inverse, right?
You know, one is the,
8 over 9.
Joey, can you put up the vector that you got for example 2?
And then why do you, how do you implement the 180 into it?
wait, just write,
Just write the answer.
What? I don't know. Show something.
We actually said.
I don't know. Find the vector. So tell me what the vector is.
So, I got to this now.
Is that in the right place? Like, is that where the vector ends up?
It's on the 90 plus 42, so it's in quadrant 2.
Is it in quadrant 2? Like, x minus x, 3 minus negative 6 is positive 9. 0 minus negative 8 is positive 8. So what quadrant does that end up in?
Oh,
the vector.
it's quadrant 1, so it's split at 42.
So it's good. So that's the check.
I think it's better if I write the quadrant 1 second.
Do whatever you need to do. Like, I usually draw it in the right spot when I find it to go from there.
Yeah, you get
So he's doing end minus start. So the vector, which he did not write, but he's now finding the magnitude for you all. Go ahead. So vector AB, he says, is 9 to 8. You guys agree?
Yes.
Okay. And then, yeah, it sucks, that board. Welcome to it. Haha. So he did magnitude is 9 squared plus 8 squared, 81 plus 64 is 145 square root of. Sorry? Yeah, it's, I mean,
The vector not be negative, not
okay,
just a matter.
it matters. So is the vector 9, 8 or negative 9, negative 8? End, what's the end coordinate, the B or the A? The B. So it's 3, as he wrote here, 3 minus negative 6. So it's gonna be the positive. So Joey, just with the way you showed this, I understand the work and all. I wanna see it put together in the end as a vector. So just like finish the piece. Mara, how do I get the direction? The y over the x, 8 over 9, which gave you negative 41? 42?
41.60, which is 40.
So it rounds up to 42? Okay. Yosef. What quadrant does this get? Quadrant 1. Is that a quadrant 1 angle?
Yes.
Do I have to do anything to it, or am I, he's like, now you're done. Done. This one up here, graphing it, negative 47. That was not in quadrant 1. I needed to move it to the right place. However, which way you want to do it, like just add 180 to that negative angle, or go 180 and subtract the absolute value of the angle, whatever you need to do. Okay. Is that not on there? It wants to know, do you know the formula? Like, so the double lines, sometimes they do that. Sorry, what does the double lines mean versus just the single line? Is there a difference, or is it the same damn thing?
Not the same thing.
Not the same thing? How's it different? It's the same thing, Serene. Just some textbooks write it different. Okay, well, what does this notation mean? What is it asking us? Magnitude. So how do we find the magnitude with those things? It's just like, it's just alphabet soup. Yeah, it's, whoops, v1 squared plus v2 squared. That's just it. It's just asking you, can you apply the formula? And we'll give you the orange sheets for the quiz tomorrow. They've got a lot of helpful stuff on there, but magnitude's there. And how do I do vector u plus vector v?
It would just be would you find basically the magnitude of both? And then,
Okay, does this have any of the bars on it? Am I asking
Oh,
magnitude? No. So how do I do vector u plus vector v? Gianna?
It would just be u1 plus v1, and then v2 plus v2. And then apples, or no.
I think you would get it right if I gave you numbers, but that this is letters, you guys are like, what?
It's not that hard though.
So
Do 100 genius.
it's just saying this. Okay,
Oh, it's the second one?
Sarah, pick 2 numbers. 3 and 4. Adam, pick 2 numbers.
1, 4, and 5.
So if I asked you to do sum home with vector A and vector B that these guys picked, what is A plus B? What is vector A plus B going to end up being? She said 5, 5. So Sarah, what she did was she took the X piece and the X piece, added them together and left it here. What Gianna did with the alphabet soup, she took the X piece and the X piece and left them where the X's are. So it's hard when it's just variables, but do you get what we're doing? And then somehow correctly took the Y's and the Y's and left them where the Y's were. That's what Gianna did also. Monica, okay? So Monica, then you get the hard one, you get to subtract. What's vector u minus vector v with the alphabet soup? Okay,
So 1, 3.
well, okay, so if we did it with the numbers, 3 minus 2 and 4 minus 1, yes. Okay? It just looks ugly with the variable soup. Okay.
Yep.
Yes, Tay? He's not high-fiving you, Nate.
My question was, wouldn't it be B1 minus B1, or it doesn't matter?
This vector minus that one.
Oh.
So,
Also just depends on.
yep, gotta watch it with that.
Miss Pascal.
Yep.
Question on this.
Okay, guys, do the magnitude things.
So this be 5 plus 22.9.
Someone just asked, that thing, is it the magnitude of u plus,
The magnitude. Yeah, right.
is that the same thing? What do you think? Roscoe, what do you think?
Whatever is, we did the number CU plus V.
Oh wait, no. I think I figured it out.
I did the magnitude.
Okay, the
Is it
person that
minus
asked the
2?
question says, no, I don't think that's it, and Roscoe, you're saying,
The answer.
Minus
I just did
I
the
didn't even read
magnitude of that.
correct. So Roscoe's saying, add them, get that answer, take that vector and do the magnitude. Yes, that's what we're doing. So you're right, it's not this.
So it's minus 2.
Emilio, how do I find the magnitude of u?
The squared.
Magnitude
That's greater.
of what numbers go in here?
2 negative 5. I mean, negative 3.
Negative.
I saw the B as U, so.
So the magnitude of that is 5. Jayla, what do you think? How am I gonna do the magnitude of v? There's the formula. What do I do? We need to do basically we're doing Pythagorean theorem of this thing has a length of 2, that thing has a length of 5. How do I find the diagonal? Pythagorean theorem. 2 squared plus 5 squared all under the square root. 4 plus 25. Isabel, how do I get u plus v given these vectors?
What do you do? Negative 3 plus.
Negative 5.
And then 4 plus negative.
Adam, how do I get the magnitude of this? Roscoe says we need to use that vector.
Just square root.
Yes,
So Ms. Pascal, what's the purpose of that?
what is the purpose of
Why is it?
this thing? Why did I circle that?
Why is W there?
I don't know. There were more questions related to it. We stole this from something and the packet was like 20 pages long. So there's more questions related to that. Yeah, I don't know. Don't ask these questions. Okay,
What's up?
can you guys grasp still? I don't.
What's up? Like the multiplication. No, I'm saying, but what was the definition of it?
The top part is hard.
Oh, I know. Dot product. Calculate impacts of each vector.
Yeah, hey, what's up?
What's the dot product? Like, how do you formulate this?
What's your question?
What's part of the dot product?
How do we do dot product?
Yeah, like,
Isn't it just the big number one?
It's not a hashtag, that means number. So the way we do it is x times x plus y times y. Can someone graph these two vectors for me? Or actually, Sarah, could you just graph u and Kai, could you graph v?
Wait, actually, I think I did.
Okay.
Kind of grapple.
You got no pitch.
Okay, just use your finger, the pen is ridiculous. You wanna use the pen, you know, you gotta not use the point. You gotta use the flat of the pen because the point. That makes sense. And so just again, go backwards.
Caution. What is going on?
I don't know.
What?
The board is possessed, so don't hate, y'all.
Starting drawing something.
So we need to plot the coordinates 6, -2. Oh, now you're in highlighter. That's the pen, and we'll make it skinny.
Sorry.
6, -2, and -3, 4.
3, 4, and 6.
Okay, hold on. All right. So that's okay. So, oh, sorry. I just erased it. Something's missing. Just fell off the phone. Okay, yeah, what's missing? He says arrows. So just by looking at them, Will, not the phones, but the board, do you think the dot product is gonna be positive, negative, or 0?
I know it's negative, I think.
If you're biking into the quadrant 2 and the wind is pushing you to quadrant 4, is the wind helping you?
No, it's negative.
So it's gonna be negative. The vectors are not helping each other. So how do I find the dot product?
So basically what you do is you do 6 times -3, and then you add that to 2 times 4, and then you get -18 plus b, which is.
Plus -8.
Yeah, -8, my bad. And then from that, you get -26.
Okay,
And this flips across.
can anyone graph u plus v? Like, if you really are biking in this direction and the wind is pushing the other one, Nick, can you come up and graph how, like, where Will's actual position would be with the wind doing this and his biking doing the other thing?
Yeah, I can try my best.
Okay? Yeah.
Is it one?
X times X plus Y times Y. And yes, and they were not understanding that V says V1, V2. So I left it as X components. So you're right.
So let's go.
Yeah.
I went to the vending machine really quickly.
No, you'll survive. You really will. Drink some of the water in that bottle. It'll build a ton.
Alright.
Okay, so he's actually adding the vectors and then doing what?
Put in the dot.
Okay, go ahead.
Is that alright?
Do what you're gonna do. Okay, so he drew in the resultant. And what I'd like to see on the quiz tomorrow, his answer is right. This is vector u plus v. I want to see them added graphically. So I'm going to pick one of them up. Doesn't matter which one. Tycho, should I take the bottom one and move it up, or the left one and move it? The left one and move it over. Okay, so I'm going to take on here. I'm going to go back 3, up 4. So this is vector u. This is vector v. And the green line that Nick drew in is correctly the vector u plus v. And, you know, Adam's like, you know, Tycho, what do you mean move the left one? We're going to move the bottom one up, dude. So that's fine. That's vector v plus vector u. We still get the same answer. The two forces are working in the same way. It's going to push them in the same direction. I's and J's on L. What was the I's and J's mean? Okay. How can I rewrite this so that it's not i's and j's, because I hate the i's and the j's?
I equal x and k equal y.
So what's the vector gonna be without the i's and j's in it?
1, 5.
1, 5. And Tycho, what's this one gonna be?
2.
2. So if you see the i's and j's, just rewrite it.
It's equal to 0. Oh, maybe the 12.
Graph the two vectors.
It's just one.
Okay. Can you plot the coordinates? Okay, so do that.
But, it's x times x. It's y times y.
Okay, so to draw the vector, go to the origin, put your finger on the origin, and draw it to the dot you made, and put an arrow there. That's it. Cool?
Yes.
And then plotting the vector 1, 5, there's the coordinate, starting at the origin. Is the dot product going to be positive or negative?
Positive.
Positive. Because they're kind of going the same way. Hi, Sarah, how you doing? You don't look happy. But you know, it's a Wednesday when it should have been a Tuesday, so we're already like halfway point of the week. There's that. She's not thrilled, people. She's not thrilled. What's your question? Or you just? I'm just. Okay. Renee, do you know how to do the dot product? So how would I do it? Now that we've translated they helped us do the i's and the j's and made them just vectors. So what is the dot product going to be? So it's positive. Miliel, can you graphically add them? Okay, do it.
Let me cook.
Her.
A string.
What?
String.
Okay, well, if I want to add this, go up to over 3, the actual added vector would be that.
Yep.
The resultant. You need to be able to do that tomorrow, people. If you don't remember how to do that, there's an old worksheet. It should be in your notebook somewhere. What's up?
Oh, man.
Probably.
Graphic, or could we add
Statement.
x plus x?
Okay, we will say
One
add
five, right?
add them graphically. You need to see the resultant.
End of 1, 5.
So what's the result?
So,
3,
Alright.
Because I have second grade.
how do you add them graphically?
Yeah, why is it not 3?
Isn't it just connecting the?
Okay. If I said,
Oh, I know. You just gotta make it fit.
Pause. Can't be saying
so if I'm giving you directions, so if I'm like, dude, go 2 blocks right, 4 blocks north. And then, pick up the whatever is there, and now go back 1 block and up another 3. So from where you are, back 1, up 3. This is how you add vectors. Like now you're there.
Yeah.
And if I said back 5 and down 8. So from there, go back 1, 2, 3, 4, 5, and down 8. It's like, imagine that each of these vectors is telling you, now that you're here, turn and go this other direction. And now that you've gotten to that place, and hold on, then the resultant, the end answer of going all those things is, if you started here, what would have been the shortest way to go? The shortest way, like instead of having to pick up things at each thing, you would have gone back 4, down 1, and then done.
Alright, but, okay.
Wait, so
How was
what's
the
the
last answer?
Did we put the quadrant? I mean,
Okay, so I'm gonna give you 2 questions at once. Hey, what was your
Can you
question?
do the last one again?
How wasn't it 3? Wasn't it? It should have been 3. Or like 7, 4.
So Nick would have just added all these together and had 2 minus 1 minus 5 is -4, and 7, like your end answer would have been that. And in the end, it's fine if you add the components.